Hello, this is Brahmani from ECEA, going to discuss about the introduction of electronic circuits. Microelectronic circuits involve the integration of tiny electronic components on semiconductor materials. They are fundamental to modern electronic devices such as smartphones, computers, and sensors. Understanding their analysis and design is essential for innovations in electronic technology. So the microelectronic circuits are very tiny electronic components on semiconductor materials. They are fundamental to modern electronic devices. So microelectronic circuits are very most fundamental components of today electronic devices, and understanding their analysis and design is very essential for innovation in electronics and technology. Basic concepts of electronic devices. Electronic devices control the flow of electrical current through various components. Semiconductors, like silicon, are the primary materials used in device fabrication. Key devices include diodes, transistors, and integrated circuits. So, the basic components of electronic devices are the electron control the flow of electric current through various components. So it will control the flow. And semiconductors like silicon are the primary materials used in device fabrication. And the key devices include diodes, transistors, and integrated circuits. So these are the key diodes. And semiconductor physics fundamentals. Semiconductors have electrical properties between conductors and insulators. Doping introduces impurities to modify electrical characteristics of silicon. The behavior of charge carriers underpins device operation. So, the semiconductors have electrical properties between conductors and insulators. Doping introduces impurities to modify electrical characteristics of silicon. The behavior of charge carriers underpins the device operations. Carriers means electrons and holes. These are the physics fundamentals of semiconductors. Diodes and their applications. Diodes allow current to flow in one direction only, acting as rectifiers. They are used in conversion, signal demodulation, and clipping circuits. These types include p-n junction diodes, Schottky diodes, and xenon diodes. So p-n junction diodes, xenon diodes are the applications of diodes, and they are used in power conversion, signal demodulation, and clipping circuits. Diodes allow current to flow in one direction only, acting as rectifiers. Transistors, BJT and FET, bipolar junction transistors, BJTs, are current controlled devices used for amplifications. So BJT full form is derived as bipolar junction transistors, are current controlled devices used for amplification. Field effect transistors, FET. FET stands for field effect transistors, are voltage controlled devices with high input impedance. Both types are essential for switching, amplification, and digital logic circuits. So these two types of transistors are essential, means useful for amplification purpose, digital logic circuits, and for switching purpose also. So BJTs means current control devices. FET means voltage control devices. FET devices are transistors with high input impedance, as well as bipolar junction transistors means they are used for amplification purpose. These are the BJT and FET transistors. Integrated Circuits ICs overview. ICs combine multiple electronic components onto a single chip for miniaturization, just as VLSI. So here IC combine multiple electronic components onto a single chip for miniaturization. They improve performance, reduce size, and lower manufacturing costs. Types include digital ICs, analogs and analog ICs, and mixed signal ICs. Microelectronic Microelectronic fabrication process. Fabrication involves process like photolithography, doping, and etching. Silicon wafers serve as the substrate of for circuit construction. Precise control during fabrication ensures device reliability and performance. So, this fabrication process involves some etc. processes like photolithography, doping, and etching. And also, silicon wafer serves as the substrate of circuit construction. And precise control during fabrication ensures device reliability and performance. Small signal model analysis. Small signal analysis simplifies the study of circuit behavior around a bias point. So, the small signal analyzer simplifies the study of circuit behavior around a bias point, and also it uses the linear approximations to analyze gain, input, and output impedance. So, these linear approximations are used to analyze the gain input and output impedance, essential for designing amplification stages and frequency response analysis. So these are very essential for designing amplification stages and frequency response analysis. DC operating point biasing. So also biasing also called as DC operating point. Proper biasing establishes the desired operating point for transistors. It ensures device linearity and stability during operation. Biasing circuits are designed to compensate for temperature and device variations. Frequency response and bandwidth. Analyzing the frequency response helps determine the speed of electronic circuits. Bandwidth is the range of frequencies over which the circuit maintains performance. Parasitic capacitances with inductances influence high frequency behavior. So the frequency response and bandwidth. Analyzing the frequency response helps determine the speed of electronic circuits, and the parasitic capacitance and inductances influence high frequency behavior. Noise in electronic circuits. Noise introduces unwanted signals that can affect circuit performance. Sources includes thermal noise, short noise, and flicker noise. Proper circuit design minimizes noise impact on sensitive applications. So here the unwanted signals and stuff are derived as noise, and that also can affect the circuit performances. Sources include thermal noise, short noise, and flicker noise. Proper circuit design minimizes noise impact on a sensitive applications. Power amplifiers and signal processing. Power amplifiers increase signal strength for driving loads like speakers or antennas. Linear amplification is crucial for audio and communication systems. Efficient power management improves circuit longevity and performance. So, this is about power amplifiers and signal processing. Analog and digital circuit design. Analog circuits handle continuous signals requiring precise component matching. Digital circuit process discrete signals using logic gates and flip-flops. Hybrid digital systems are common in complex electronic devices. CMOS technology and its advantages. CMOS, complementary metal oxide semiconductor, offers low power consumption. It provides high noise immunity and scalability for integrated circuits. CMOS is widely used in microprocessor, memory, and digital logic circuits. Design methodologies in microelectronics. Top-down design starts from system-level simplification to circuit implementation. Simulation looks like spice and essential for analyzing circuit behavior. Reliability and testing of microelectronic circuits. Testing ensures that circuits meet simplification specifications and are free of defects. Techniques such as burn-in testing and fault simulations are utilized for quality assurance. Emerging trends in microelectronics. Integration of nanotechnology enables further miniaturizing of devices. Development of flexible and wearable electronics expands application areas. Quantum dot and spintronic devices represent future directions in electronics. Challenges: managing power consumption, heat dissipation, ensuring compatibility and scaling with Moore's law presents ongoing challenges. Future outlook. Conclusion. Microelectronic circuits are foundational to modern electronic technology. Analyzing and designing these circuits require understanding device physics and circuit theory. Ongoing innovations will shape the future of electronics in various applications. Future outlook. Advance in materials and fabrication will push the limits of device performance. Artificial intelligence integration will require more sophisticated circuit architectures. Continued research will lead to more energy efficient, smaller, faster electronic devices. Thank you.